13:01 Uhr. Und ich würde jetzt mal so sagen, so im Minütchen oder in 30 Sekunden legen wir einfach mal los. Gebt ihr mir ein Zeichen? Ich kann auch noch Posen machen. Kannst du auch anstellen? Nee, das kann ich nicht. Wir sind schon live? Man hört uns da draußen? Das ist schön. Also heute ist ein wundervoller Tag. Draußen scheint die Sonne. Wir sind in Wiesbaden und in der neuen Event-Location endlich mal, wo wir den TechTalk seit langer Zeit, und ich bin ja gar nicht da gewesen in dieser Zeit, aber seit 2 Jahren nicht mehr in einer Präsenzveranstaltung veranstalten konnten. Und heute ist es uns gelungen und wir dürfen das hier tun, damit weihen wir diese kleine Location, klein, ne? Ein. Und ja, was haben wir mitgebracht? Das Thema Google Cloud in den TechTalk, das ist der TechTalk Nummer 64. Building Real-Time Data Products on Google Cloud with DataCater ist unser Thema. Es geht natürlich immer um Daten. Heutzutage, wenn man in Unternehmen weiter wachsen möchte und einfach kluge Entscheidungen treffen möchte hinsichtlich ja, können businessrelevante Entscheidungen sein, können aber auch schlaue Entscheidungen sein, die vielleicht Effizienz bedeuten, woraus man schlaues Wissen wiederum erzielt, woraus man dann wieder weitere Entscheidungen drauf basieren kann. Und damit beschäftigen wir uns heute mal, wie man diese Daten eigentlich überhaupt erstmal erfassen kann, um daraus dann schlaues Wissen zu erzeugen. Das ist quasi der zweite Schritt. Und wir sind heute am ersten Schritt. Wie binde ich denn meine Datenquellen überhaupt an mein Data Warehouse oder was auch immer ich im Unternehmen betreibe an? Und dafür dürfen wir heute den Stefan Sprenger begrüßen, der gerne mal auf die Bühne kommen kann. Wundervoll.
Deutsch oder
Und
Englisch? Deutsch oder Englisch?
I'm sorry. This should be in English, actually. So this was your chance to actually use the AI of Google to click translate. So maybe you skip to the beginning and switch it on so you can see it in English. And then the rest of that will be in English, actually. So we have Stefan Sprenger. This is still a German word.
The last one.
Yeah. And so we're going to start. So,
Right.
your stage.
Thanks a lot for the kind introduction and also having me here. So I'm Stefan, co-founder at DataCater, a young startup. We're actually remote first, but most of us are based around or in Frankfurt. We built a cloud-native real-time data pipeline platform based on Apache Kafka and Kubernetes. And today's talk will be about data products, real-time data products. So first we set some context. Then I'll give you a brief introduction to our product and show you how we deploy it inside the Google Cloud environment of our customers and how they use DataCater to build real-time data products. And in the end, I'll conclude with some learnings that we've made over the last 2.5 years. And I hope for some exchange with you. And since this is the first in-person talk that I give since February 2020, I have one question to the audience. Are there any users of Apache Kafka or Kubernetes here, or made some experiences? Okay, cool. You can never do that in a Zoom call, so I had to grasp the chance. All right, so let's start. What are data products? So as a company, you have lots of different data systems, data silos, data sources. Like you have lots of transactional data about your core business. You may use some external data, data systems, maybe like a Sendesk API of your support system. You may have semi-structured or unstructured data. And in the past, when you try to answer a question for the business with the data, you pull together like a project team, you implemented the use case, let's say maybe revenue forecasting with technology that you chose at the beginning of the project. And it was very hard to transfer the work from one project to the other, so there was no standard. And that's being solved with data products. So data products aim at kind of standardizing the implementation of such use cases and aim at providing prepared, clean data sets to various downstream consumers. Could be a reporting application, could be an app, could be a dashboard, whatever. And you organize these products in terms of the kind of data that they resemble. So you might have customer data that can be consumed by someone in your organization, supplier data, etc. And when we talk about real-time data products, you of course want to also serve fresh data to the consumers. So you don't want to serve the data from yesterday or last week, but enable them to work with most recent data in their use cases, applications, etc. And we are a bit biased here at DataCater because we really focus on the real-time aspect of data pipelines, but we basically use a streaming or real-time data pipeline as the base for the implementation of such data products. And they take care of consuming data from a data source, could be transactional data in a MySQL database system, streaming the data to downstream to a downstream place where it can be consumed, could be maybe data warehouse. And of course, they don't have to only copy the data from A to B, but can also filter, transform, clean the data such that you can deliver high quality prepared data to the consumer. All right. So the traditional approach to extraction of data from a source system is like batch-based. So maybe you run an ETL pipeline every night at 2 a.m. and get all data from your transactional data store. We don't do that, but use a approach called change data capture. So instead of loading all data with each run, we continuously monitor the source systems, like a transactional database system for changes. That means inserts, updates, and deletes. And whenever there's a new event, we stream it to the downstream data sync, such that the consumer can always make use of fresh data. The technology that we use is not new. So Apache Kafka is around for more than 10 years. These concepts are not new, but what we're trying to innovate on is we aim at making these technologies more accessible. So in the past, you still had to become an expert in distributed computing, still had to learn about all the details of Kafka and related technologies to make use of it. So they were kind of reserved for the streaming experts, and what we're trying to solve is make these exceptional technologies more accessible and have the data and developer teams out there to benefit from the power of event streaming, of real-time data pipelines without having to handle its complexity. And that's basically our idea. And how we approach that problem is we kind of introduce a declarative layer above Kafka and the other technologies, which allows teams to use an interactive UI or YAML definitions or descriptions to build these streaming data pipelines in iterations and deploy them in a matter of minutes. So, well, before you spend maybe days to weeks on implementing a specific real-time data pipeline, we aim at reducing the time needed to build that to 2 minutes. And what we then take care of is compiling this declarative data pipeline definition to a production-grade Apache Kafka Streams application. I think it's a bit too low on the screen, but I hope it will be clear in like 1 or 2 slides. And then run that Streams application as an elastically scalable deployment on Kubernetes. So as a developer, you no longer have to deal with Kafka directly or Kubernetes, but can build these pipelines and deploy them on stable, proven technologies. So try to avoid to put text on each slide, so I have only like a very short video. I also don't want to use time for like a real demo or something, just to give you an impression. How we make streaming data pipelines accessible is we have this interactive UI, which you can use to build transformations on a sample set. And once you're good to go, you can deploy that to Kubernetes. And while you build the pipeline, you get like a preview of the potential outcome presented on the sample in a spreadsheet. And this UI, so we also made the experience very early on, like building just a UI will not work for developers. So this UI is based on a YAML format for pipelines. That's like 100% compatible with the UI and represents a streaming data pipeline. That gives us a textual description, allows us to perform GitOps, so you can put that pipeline definition, that declarative definition, into like a Git repository and let DataCater handle compiling this declarative definition to actual code and deploying that to Kubernetes. We get version control for free. That's very important. If you have an UI or like a no-code or low-code tool, you need to give users tools to version things. And yeah, for those with experience in Kubernetes, that's looking a bit like a custom resource definition. So we are also leaning towards the lingua franca of Kubernetes there. With regards to the architecture, so I already told you that we base everything on Apache Kafka and Kubernetes. So at the top, there's this UI-based pipeline designer. There's this YAML format. We call it the declarative layer. And what you can then imagine is you give us the YAML, or you use the UI to create the YAML, and we transform that into Kafka Streams application, which kind of connects to Kafka topics. So we have like raw data sitting in like a source topic, and the pipeline streaming the data from the source topic to the sync topic, and applying transformations, filters on the way. So think of maybe like a GDPR transformation to remove sensible data before handing the data to downstream consumers. And for the compute, we package the Kafka Streams app as a container image. So once you create like a deployment for the pipeline, it's immutable. You can no longer change it, except if you would create another deployment, and then deploy that container image on a Kubernetes cluster. of course, when we think of data product, we can be quite confident that the data of a company is not yet living in a Kafka topic. So we somehow have to take care of extracting change events from a MySQL database, or maybe loading CSV files from a Google Drive into a Kafka topic. And to this end, we make use of Kafka Connect. It's an open source framework for integrating Kafka topics with external data systems. We use that on the source side. Also heavily employ change data capture, so we use that for the database systems, but also for a Google Cloud storage. So we detect changes in a cloud storage, like a bucket or folder. We can use that even with like a Google Drive, with a REST API, etc. And not only on the source side, but also on the sync side, we could think of maybe a BigQuery connector, which then integrates the sync topic holding the clean prepared data with BigQuery or another downstream system. And as base technologies, we use Apache Kafka for storage of messages or events. We use Kafka Connect for the integration of the Kafka or internal Kafka topics with external data systems. We make use of PostgreSQL as like an internal state store for persistence, and heavily use Kubernetes. And we have like a managed offering of the product, but also on-prem installations. And for Google Cloud, so we have mainly on-prem installations running on Google Cloud. We map the different technologies as follows to the services. I mean, on Google Cloud, you can use a managed Kafka service, Confluent Cloud, for instance. We don't use that, but deploy Kafka and Kafka Connect on Google Kubernetes engine using a operator called Streamzy. Main reason is we need to make some adjustments which we can't do with managed services. So for Kafka, we're a bit more on the custom side, but can deploy everything on Google Kubernetes engine, and Streamzy takes care of operating Kafka on that Kubernetes cluster. PostgreSQL, for that we use Cloud SQL. It's a managed service, very robust. We don't have to worry about managing our database system used for the state and persistence. So we are super happy with that. And for Kubernetes, of course, we use the Google Kubernetes engine. So GKE is short for Google Kubernetes engine. Super happy with their offering, and the container images, which somehow belong to that part, are stored in the container registry of Google. So when you create a pipeline in DataCater, create a deployment for that, we actually build a container image and then push it to the container registry of Google, and can then schedule a deployment in Kubernetes with that container image. I don't want to rush through the slides. Do you have any questions? No questions so far. Did I lose anyone? Okay. All right. For those folks who are interested, we do have our Helm chart public. It's also kind of customized for Google Cloud, so that allows you to perform like 1 or 2 commands on the command line to deploy DataCater in all dependencies, including Kafka, etc., on the Google Kubernetes engine, or like on a cluster there. It's on GitHub for those who are interested to dig into the details on how we deploy DataCater on Google Cloud. When we leave the architecture side a bit and think about like data products and which systems are in use and how they're used on Google Cloud, we have to think about sources and sinks. One of the most commonly used systems is Cloud SQL, whether it's MySQL or Postgres. It's like everywhere. And the nice thing about Google Cloud is these days they also offer replication logs for all of the database systems in Cloud SQL, which allows our source connector to extract the events in real time without putting load on the database system. So we don't have to run like select star queries to consume data from Cloud SQL. Cloud storage is everywhere, so CSV files are still a thing, and they're stored, or other formats, flat files, and they're stored on cloud storage. We can't detect changes as efficiently as with Cloud SQL, but what we can offer there is we pull the state of cloud storage every X seconds and use the timestamps or the files to detect changes in files. So it's like a bit tacky, but works efficiently. The same can be done with Drive. So whether you have like a sheet in Drive that's maybe changed by users manually, or load some CSV files into a Drive, you could again use these timestamps to detect changes and then extract the data from Drive. And even BigQuery is sometimes used inside the environment of Google Cloud as a source. So sometimes it's also used as a source. And then but for BigQuery we use the select star query to extract data. And of course you don't only have these internal source systems, but also lots of external ones like APIs living outside of Google Cloud, like a Zendesk, like a HubSpot API, etc., which you might want to consume, where you might want to extract the data from and then use it. And the most popular systems for the sync side are, of course, BigQuery, so that's heavily in use at all Google customers, I think. Very powerful cloud data warehouse. We're also big fans of it. A bit Cloud SQL and some external APIs which you might want to feed data to. I also brought an example from a customer which built some kind of product around usage data of their SaaS application. So they run their services on Google Cloud. They have a SaaS application, and under the SaaS application there's Cloud SQL persisting all the data. And they build streaming data pipelines which consume the changes from Cloud SQL in real time using change data capture and feed the data to BigQuery, but also to some other external systems, so like an accounting application and a CRM. Apologies. So they built one data product around usage data, and the impressive thing is they even use that product for billing, like sending out invoices to their customer. So they don't only do reports on top of the data coming from the SaaS application, but really send the usage data to their accounting tool and then build the invoices.
Yeah, there is a question. So let me walk over there. Oh no, we have a second microphone.
Hi, Stefan, could you explain a little bit more for such usage cases, what they are doing with the data once it's in BigQuery? So what kinds of outputs your customers are typically using?
In BigQuery, yeah. So, I mean, you could either run SQL queries directly on the data, or they typically plug a BI tool or like a dashboard or reporting tool to BigQuery and visualize the data.
Sorry. This goes into business intelligence then, mainly?
Yeah.
Okay.
All right. We get often asked, how do you scale these pipelines or products. So the cool thing about Kubernetes is you can start with a small cluster. So I mean, back in the days, you had to buy a large on-premise cluster. You had to buy or lease all the machines and put them into your basement to plan for maximum load peaks. But with Kubernetes, you can deploy your services and also the pipelines or data products on a Kubernetes cluster. You can start with a certain number of VMs. That means compute engine instances in the case of Google Cloud, which power that Kubernetes cluster, let's say 3 or 5 or whatever. And the different services specify their resource requests. They tell Kubernetes like, hey, I'm a new pipeline, I need 0.5 virtual CPU cores, I need like a gig or 2 gig of memory. And once the cluster enters a state where it can no longer fulfill the resource requirements, it can spin up another VM to then scale the cluster up. And of course, once the workload goes down, you can again scale down. That's also quite cost efficient, especially if you maybe combine commitments with spot instances. Like you commit for a certain number of VMs for a certain amount of time, like where you're sure that you need them, and all these sudden load peaks you handle like when they come. So cloud does not have to be super expensive. I mean, it comes at a certain price, but you can definitely optimize it. Question or?
Könnte ich mal? Ja.
Okay.
Noch eine Frage
you looked like you
von
had
Bob?
one, but
I would actually start with a question. Yeah.
Okay.
What happens if the service drops? Like, I mean, you're constantly streaming data, but then let's say any service drops anytime. What happens with the data? Is it just a dropout? Is any data getting lost? Or what would be the consequences of that?
Yeah, you mean like when maybe a database system which you use, like a transactional database system which you use as a data source drops for, let's say, 3 hours, what happens? So these source connectors persist the state of the system that they have seen the last time, also successfully consumed. So think of, if we think of a Google Cloud Storage, we persist the timestamp, which we have most recently seen. When we talk about database systems, it's like a certain line in the replication log. And so let's say the database system goes down. When it comes back up, we can continue extracting data. And I mean, there could also be the case that maybe DataCater goes down. I mean, no system can guarantee 100% uptime. Then we can also go back to that state that we've most recently seen and persisted and continue from that point on.
So that basically means that all the data is in the warehouse, and then you have incremental updates. And just the incremental updates are missing then for a certain time, longer than normal, and then the increment will be bigger.
Yeah, but we actually start with the incremental updates again from the most recent, let's say, point in time that we have processed.
Okay.
Yeah.
What's normally the way you work together with customers then? Is it that they can just run some trial and just try it out, and then they deploy it by themselves and just learn by themselves how it works? Or what is the deployment model there and how you work together with customers?
For Google Cloud, for the on-prem installations, I mean, we have the managed service. You can go to a website and start a trial. But for Google Cloud, we've made the experience that it works best when we start with an initial project, like a POC of 2 to 3 months. Also contribute some resources from our side, help with the setup and guide the customer a bit, and then help them to walk alone and manage everything on their own, just to really guarantee that it will be successful.
which means it's an on-premise means that there's a project running inside of Google Cloud.
Yeah, sorry. When I say on-premise, it's not the dusty server in the basement, but it's like not something that we operate, but that's running on hardware rented by the customer. I think we need a new term for deployment inside the cloud environment of someone. Okay. Yeah, there's the next VM and the next one coming up. And you, of course, not only have to scale up, but can also scale down. And the same can also be used with pipelines. So, of course, there are certain limitations of how many changes a pipeline can process per second. So if we think of a data pipeline running as a Kubernetes deployment, syncing maybe Cloud SQL with BigQuery. So we have like a rule of thumb that it can process up to 5,000 events. Depends on different factors, like also size of events. Like a table with 300 columns will see a lower value here than a table with 5 columns. But that's like a rough estimate. And if you run it as a Kubernetes deployment, we can also let Kubernetes handle the scaling. So it's a good thing that we don't have to do that because it's complicated. So we can define metrics which are used by Kubernetes to launch additional instances of the same pipeline. And then the load gets automatically distributed among the different pipeline instances. So let's say we say that once the CPU usage of that pipeline is above 80%, Kubernetes shall launch as many instances until it gets below the 80%. And of course, it can also work the same way back, like in the other direction, it's getting down. Okay, then before we come to an end, some small learnings that we have made. So first, some kudos to Google Cloud for building cool services, which I think paved the way for real-time data products. So we are big fans of BigQuery. We have worked with I think it's okay to name products, Redshift and Snowflake, and BigQuery is the first cloud data warehouse which offers streaming ingestion API. So you don't have to put CSV files, don't necessarily have to put CSV files in a cloud storage and then load them into BigQuery, but can use their streaming API directly. So can have really like a real-time insertions there. I know that others are working on that. So Snowflake is investing heavily into the streaming space. Redshift has announced that they will soon offer a streaming API, but for Google BigQuery, it's like around for years, so that's super cool. Also for Cloud SQL, they have made lots of improvements. So this log-based replication was not available. It's not available forever, but for instance, I think for PostgreSQL, it's since around 1 year or something. They have been a bit behind other cloud providers there, but nowadays they offer it, so that makes us happy. And yeah, I mean, that's nothing special about Google Cloud, but for all these services like BigQuery, Cloud Storage, Drive, etc., you can always fall back to that timestamp-based change data capture implementation. And yeah, if you want to explore Kafka, you can use Confluent Cloud there, which is directly integrated into Google Cloud. Also quite cool that they let vendors offer managed services there and don't try to rebuild everything on their own. So give it a try. These were some happy words, some not so nice things. Logging, for instance, we made our experiences there. So, I mean, logging is super crucial. We since we run all the pipelines, data products in Kubernetes, we also produce logs there, and the Google Kubernetes engine natively integrates with Google Logging, which is cool because then we can just go to Google Logging and see what is happening in a certain pipeline.
What would be the actual consequence you had from not logging properly?
No, there's it's not black or white here, but there's lots of space in between. So let me build up the case a bit, and then I can tell you our consequences. So you can actually also define some log-based alerts in Google. So I mean, we see which data is flowing through the pipeline, whether it's something that we expected, or whether maybe there was some faulty data there. So you can actually build alerts based on the logs, which also incorporate business logic, which can notify users, etc. So it gets a bit expensive. So by default, you have a quite long log retention, which is, I think, 30 days, which you might not always need. And when you have lots of logs stored there in Google Logging, the invoice at the beginning of the next month will also be super huge. So we made the experience. You have to be really careful with with logging, and one of the first things there that we tell customers is, hey, please maybe adjust the logging configuration and don't hold all logs in Google Logging, because I mean you can actually maybe after a certain retention period just kind of offload your logs into Google Cloud Storage or something much cheaper than Google Logging to save costs. So that would be the consequence. Tuning the logging a bit. Also, we made the experience that's not Google Cloud specific, but more like Kafka or real-time specific. But Kafka Connect does not really offer self-containment, something that we are used from services like Kubernetes, where we can specify individual resource requirements for specific workloads. And for Kafka Connect, that's not possible. So you have so it's like a distributed connector tool or framework, and you have multiple connectors running in the same process. So although you can easily operate Kafka Connect on Kubernetes using Streamzy, for instance, it's quite straightforward. It's not yet fully using the strength of Kubernetes. So we don't have isolation of different connectors. And if one connector goes rogue, something very bad happens. Let's say someone maybe dumps a super large file in like a Google Cloud in Google Cloud Storage, and it loads everything into the memory, and then all the other connectors running in that same process are impacted. So that's super painful, and we're working on a fix here, and hopefully can also contribute that to the rest of the community. And that's it. Thank you very much.
Okay, thank you, Stefan. Actually, to take this to real life even more is like we can make that example of Seibert Media. Basically, it's a company like here in Wiesbaden. We have 260 people. We create a lot of customer data, also like on contact base, like on HubSpot, and we are basically building on Kafka. Mm-hmm. So it's directly on Kafka. So what would be your pitch actually to sell your tool? Like, or what would we actually, where is the benefit to actually bring it to company which is building right on Kafka?
Mm-hmm. I think I would ask the developers working on Kafka in the company, like how long do you need to build a certain exemplary data pipeline? Are you the only ones who can maintain, manage it, or are there also others in the company? So like I think we accelerate the time to production a lot, and also make Kafka accessible to all the developer teams in for instance, Seibert Media. I don't know how many people are working on Kafka in Seibert Media.
I would say just maybe 2, 3, I would guess. 4 or 5, okay. So it's getting more.
It's getting more,
the
but
company
but
grows.
they still have to I think learn a lot of the about the internals of Kafka, and our dream vision is that if you're a developer, you can make use of that technology.
So basically, you don't have to know Kafka, but you can basically do almost the same things like in a UI.
Yeah, or like a YAML description or APIs, CLI tool.
Okay, so it takes out a lot of complexity for the users.
I mean, if you remove that, like in the architecture, if you remove that layer that we introduced, you still need to program these Kafka Streams application by hand, and that takes some time, and also to ship them to production takes some time. So we are reducing that by a lot.
Okay, I would actually look into the audience. Is there any additional questions? There's a question.
Yes, what about looking at all of this Kubernetes and multiple cloud services at from an operations perspective? What kind of monitoring and observability can be put into all of this to know where maybe the data stream stopped and when it stopped and why it stopped?
That's a great question. So we don't want to build a monitoring tool, but just integrate with the existing ecosystem there, so you can continue using your monitoring tool. And we expose metrics or health endpoints for pipelines, which you can use to call, maybe build some custom dashboards there. You can, of course, somehow use the logs to observe the state and the health. Yeah, I think these are the things that we offer there.
And do we have another question?
Yes, Stefan, hi. I was wondering if self-containment is something that everybody knows here as a concept. I must say that I'm a little bit unknowing about it. Maybe you can explain this.
My apologies. So, I mean, basically, if you have a connector which consumes or which sends data to BigQuery, I want to specify how many virtual CPU cores and memory that connector is allowed to use. And if the connector goes beyond that, I want to let Kubernetes handle that situation. And I don't want to let that connector break free and impact all the other connectors. I don't know whether that's a good explanation, but you have to give me feedback. It's I speak not as Stefan, but as maybe a happy operator.
Yes, but self-containment basically means that something, if you're running a Kubernetes cluster, no matter what kind of application it's on it, that the application doesn't need to care about load or capacity, scheduling, stuff like that. That is a task that is taken over by Kubernetes itself.
Yeah, also
right?
resource requirements. So now we're getting very Kubernetes-ish, but for resources in Kubernetes, you can let them define their minimum needs. They can request a certain amount of CPUs and memory, and they can also define limits. And if they hit these limits, Kubernetes will basically stop that process and restart it. And I think that would be handy for connectors, such that you don't have a single connector taking down all the other connectors, because then at some point the Connect cluster is hitting these limits in Kubernetes.
Yeah, let's look a little bit into the future. What are your plans like on future features, or like the direction you're taking?
We are at the moment heavily working on the developer experience. So that's something that we really want to nail and double down on. So I would say developers. That's,
so to get more access to like really building.
No, at the moment we don't have a CLI tool out there, for instance. I think that would be quite handy. Yeah.
Okay, that makes sense. Do we have other questions? No. I actually have like an interest in what would be your kind of like, if you say like your sweet spot, what would be the kind of company which is perfectly made for DataCater? So what are you at what maturity stage maybe that goes into that direction would be a company? What size of a company would it be? Where would it be really, really helpful to have DataCater help building more data pipelines?
Good question. So, I mean, we're quite young, quite early in our journey, so we at the moment don't focus on the very large enterprises. We also don't think that like a small company with, let's say, 10 or 20 employees will benefit a lot from our product. So in terms of company size, we may focus on like 50, 100 employees to maybe 1,000. And I think it's also important for us. This whole technology is super early, so there should also be some kind of prior expertise, knowledge in data engineering. Maybe some first 2 or 3 people who have worked with Kafka and really want to expand that to other use cases.
Okay, so all the best for your future journey. And I would say if there are no other questions, I would like to add like a few words just about Seibert Media and this new event location. It's our first Tech Talk here, which is pretty interesting to see people again when you have a Tech Talk. You used to have it online actually, so you look into like your computer, and now you can actually see people and it has depth. That's pretty exciting, and we'll have a lot more of that because it's a new event location, like I said. So the future will be more physical events again. Also, we have an open office, which, can you update me? Is it a Friday afternoon, 4 p.m.? I think every third Friday. Yeah, I think you can find it also on the websites. If you want to look into Seibert Media, we will have like future events again. It was, the past 2 years, that was online. That's how I actually got to learn of this company. I was there and I just saw like 10 people in a chat, and we had a conversation like here, just really, really informative. But in the future, that will be real life again. So people can be here and actually see the location, not only this location, we have 4 locations here, and let's see how that actually develops. Depends also on like how many people will be here. And like today, you'll get something to drink. That's always inclusive, and maybe a little bit of food also, so that you can actually have a relaxed conversation. So thank you very much again, Stefan. And I would say that's it for today.